Linux kernel. Linux kernel is the core of the Linux operating system. Okay, in the Linux kernel consists of Linux core and the Linux kernel modules. So core provides the all the necessary features uh, of the operating system, and these essential features are extended by various modules. So there are different type or categories of modules for keyboard modules, drivers, firmwares, all type of modules comes under this Linux kernel modules. These modules helps to extend the basic functionality of the Linux kernel core. So the user applications connect to this module, and these modules provide the link between the hardware and the operating systems and get back the result from these things to the user application or the user space. So the basic structure of a Linux kernel module have a module initialization and a module exit. In the module initialization, it's like a hook. It consists of a underscore init. So this is uh, an example of module initialization. This is where we put all the initialization things of the module. This we can say that this is the entry point of this module, and this is the exit. This is the exit function. It will act as an exit. Here we can provide all the cleanup functions of that modules. Okay, in this episode we are going to create a keyboard counter, which means that we are incrementing a counter whenever there is a keyboard press. So we are going to create a character device or character driver. So this input is from the keyboard, and this data from this keyboard is as like a continuous flow of data, and this continuous flow of data is captured by the character device, and the user or the application is can access this character device and the data using a character driver. So in any kernel Linux module, we have kernel driver within which is written in which is usually written in C language, and there is a make file in order to make this thing. So as I mentioned before, we have a module entry point. This is the module entry point init, and we have the module exit point. This is where we unload the Linux module, and in this init we are actually going to load the this module. So we are going to create a keyboard key press counter. Okay, for this thing we have to know whenever there is an interrupt in the keyboard. So we are using this type of a hook in order to get the um, this interrupt. So this IRQ is the interrupt which is issued or which is emitted by the keyboard interrupts when there is a key press. So in this thing we are actually going to increment this key press counter increment, and by doing this dev read we actually get the key press count, and we output this key press using the print k method. Okay, so in any type of character driver or character device there are some common functions are there, like read operation, open and release. This type of open operations will be there, and we are using this struct in order to map this common function to our our own function. Okay, so in this init module we will first of all we register this character device. These are the things, to register the device. It will allocate an entry point in the dev folder, and we are also registering this IRQ handler. This IRQ will provide the whenever there is an interrupt in the keyboard. Okay, and this print k method is a kernel specific method. It will print this type of output to the kernel. So now we are going to demo this kernel module. So in this key press counter module, we have two files. One is written in C language, one is a make file. After completing this thing, we make this module. After that, we load this module using this command. So this ko is the extension of the file after we are doing this make. So now we load the key press counter module to the module, and now we want to know what's the whether it is loaded to the Linux. So we can say that, sorry, we have to provide this sudo. This might be been okay. So this key press counter is loaded. Now we want to write some key presses like okay. So we have to just press some keys in order to increment the count. Now we need to know. Okay, so we have to again give the sudo. Okay, so the key press count is 327. So this is a simple demo of how to create a basic Linux module, how to create a driver, how to create a character device, how to load and unload the module, how to utilize the printk function.